Hello everyone, my name is Evangelos.
And I'm Lukas.
And we're going to be presenting the Koala benchmarks for the shell.
Hold on, Vagos, the shell? Are you talking about like when I open up a terminal and poke around in the file system a little bit? Like what kind of serious work are people doing in the shell?
Well, the shell is used in a number of different domains. For example, bioinformaticians take advantage of the fact that there exist some high-level, highly optimized utilities, and they're using the shell to orchestrate them. Similarly, the shell is a very natural platform to encode data science pipelines. The shell is also used heavily in places like CI/CD, system administration, natural language processing, and more.
Yeah, in fact, now that you mention it, the shell has been in the top 10 programming languages on GitHub for the last decade.
Exactly. And this practical interest in the shell is being reflected in academia. And the past many years, there have been a lot of excellent works that improve the shell towards making it more expressive, secure, or performant.
Okay, so clearly everybody loves the shell. What's the problem, Vagos?
There is a slight problem. So, if you look at this first quote, and people might recognize the name of the author, if you watched today's OSDI keynote, essentially, in the paper Optimizing Shell Scripting Languages, the author built a system, but they didn't have a set of established programs written in the shell in order to evaluate it with. Why is that a problem? Okay, first of all, it's very expensive. You not only have to, of course, build a system, you also have to curate the collection of programs to evaluate it with. And then also, if we move at the second quote, which is 17 years later, still no benchmarks. The authors there have to explain why the benchmarks they collected are actually representative and useful for evaluating their system. All in all, this slows down innovation for the entire community.
Okay, Vagos, but I don't think I get it concretely. What's an example of a real shell program that people have written that would make for a good benchmark?
That's a great question. So I'm going to show you an instance where researchers collaborating from various institutions, they wanted to digitize the oldest religious texts in humanity's history, the ancient pyramid texts. So the story goes as follows. A sub-team of these researchers went to Egypt. They visited the ancient pyramids, they went inside, and they took a bunch of pictures of the walls. What they need is a pipeline that will convert these images to a form that is amendable to further search and analysis.
Nobody's going to write this as a shell script, right?
Can you believe this guy? Yeah, this is the actual shell script that was used by the researchers. It does a lot of interesting things. Let me walk you through it. So first, the script takes an image. This is a picture of the wall. It then pipes it to a segmentation model that tries to identify regions of the image that could be a hieroglyph. It then computes a bounding box around each one of these regions and redirects this information, 4 XY coordinates per bounding box, to a file. It then takes this file again, pipes it into a classification model, which takes alongside the image, and the classification model tries to predict for each one of these regions what hieroglyph is depicted there. Then finally, this mapping between the image name, the region coordinates, and the predicted hieroglyph is sent to standard out. And this process is repeated across all of the images in the expedition, and a database is created.
Oh, that's pretty cool. And now that you've walked through this, I think there's a couple of ways we can make this script faster. You know, like you mentioned that paper before, we could apply some transformations to the script to remove some unnecessary I/O, and that should make this program faster. And actually, there's this system I saw on Hacker News a little while ago called GNU Parallel. You could rewrite the script a little bit and then run all those loop iterations in parallel. I bet you get great speedups if you did that. And actually, there's also this other system called PASH, which can introduce data parallelism in all the stages of these pipelines. And I bet you get awesome speedups from that. Oh, and there's even the system called HS, which can run pipelines speculatively. It could run all these pipelines in parallel across all the loop iterations. You get insane speedups if you did that.
Wait, Lukas. Okay, I love the enthusiasm. I love these 4 systems, but let's take a step back. Okay, say that these 4 systems indeed improve this one script. How can we tell that the results generalize across many different shell scripts? Can we be a little more scientific about that?
We need a benchmark suite, don't we?
Exactly. And this is where the Koala suite comes in. Koala is a set of real programs written in the shell, accompanied by real inputs in multiple sizes and permanently stored. Each one of the benchmarks has been extensively characterized across many different dimensions. And it all comes with automated and configurable infrastructure.
Okay, but where do these programs come from? Did you just write them yesterday, Vagas?
Not quite. So these programs come from various different sources. Some of them come from the general internet zeitgeist. Some of them are historic shell programs. Others come from popular blog posts where people use the shell in useful and interesting ways. And others come from academic works. Koala covers all of the domains that I mentioned people use the shell in and more. Each one of these circles in the Venn diagram corresponds to Koala's internal categorization of each benchmark. The size of each circle is the proportion of the presence of each domain inside the suite, and intersection between two circles means that some benchmarks belong to more than one domains.
Okay, so clearly these programs come from a diverse set of domains, but how do we understand if these programs are actually different from each other, like their intrinsic characteristics? That's
a great insight. So indeed, we need to understand these programs. We need to extract information about them in order to arrive at conclusions like, is the benchmark suite diverse? The way we did that is we applied a set of analysis like semantic analysis, runtime orchestration, in order to extract a bunch of information and arrive at results. Okay, so I'm going to zoom in into one of the plots that are part of the static characterization of the Koala suite. This heat map has columns that correspond to the different benchmarks and rows which correspond to the features of the shell language. These are features like pipelines, redirection, for loops, etc. Each cell inside the heat map signifies the number of times each feature appears in each one of the benchmarks.
This is pretty interesting because in my experience with shell scripts, there's kind of two different kinds of scripts out there. There's really simple scripts that run a couple commands, maybe sprinkle a couple of pipelines in there. And then there's really complex scripts that use the whole shell programming language. And I see that Koala has a nice coverage of both of these kinds of scripts and a variety of different diverse uses of these different features. And actually, I see from that rightmost column that across the entire Koala suite, every single feature of the shell language is used.
That's exactly right, very perceptive. So moving on to the dynamic characterization, we then again zoom into one of the plots. The x-axis here again is each one of the benchmarks, and the y-axis is the log of the time the CPU spends either inside the shell interpreter, shown by the blue lines, or outside of it, running external commands and utilities, shown by the green line.
Oh yeah, that's important because if you're optimizing shell scripts, you might want to optimize the interpreter itself or optimize the amount of time it spends executing external commands. That makes sense. And looking at this plot, I see you've got some nice diversity. You've got some short-running scripts that run for a couple of seconds. You've got some scripts that take hours to run, and everything in between. And you've also got a nice mix of scripts that spend a lot of time in the shell and a lot of time in external commands.
Exactly. And we actually went ahead and ran a bunch of other analysis on each one of the benchmarks. We extracted information such as the exact commands these benchmarks are using. Other information like the system calls they're executing, their memory intensity, I/O patterns, and more. All this information, as well as additional insights, can be found in the paper.
Okay, Vagas, I'm convinced I need to use the Koala suite. But you mentioned automation and infrastructure, and I'm kind of lazy, so tell me, what do you have for me?
Okay. Let me walk you through it. So Koala comes with this light harness so each one of the benchmark sets has a folder called scripts. In there we put in each one of the benchmarks, and it comes with this light harness. So the harness, what it does is it first starts up a sandbox. It installs all software dependencies required to run the benchmark. It fetches all of the required inputs, and these range from minimum inputs just for testing up to large inputs meant for large-scale characterization. It executes the benchmarks as part of that set, and then verifies the outputs against pre-computed values so that you're certain that your optimization or system didn't break anything. it finally produced a report with information like runtime, memory usage, I/O, etc. Every part of the harness is configurable. Like, for example, you might want to only fetch the medium-sized inputs because you want to be done. You can disable parts of it because, say, for example, your system doesn't expect to be run inside the sandbox or brings its own. And we've put a lot of care into making the benchmarks repeatable. The harness cleans up the environment so you can repeat the execution as many times as you want.
Okay, I mean, this all sounds great, but how do I know it fits together in a nice, complete package? Have you tried this out on a real system?
I did. So I actually took these 4 systems that you showed me, and I applied them to the entire Koala suite. Here, I came up with these 4 plots. The x-axis of each plot, again, shows each one of the benchmarks, and the y-axis shows the relative speed up that each one of the benchmarks achieved. Sorry, each one of the systems. You'll notice first that the y-axis of each plot is different. The point here is not to rank these systems against each other, but rather show that they have different strengths and weaknesses across the suite. And also you'll notice for some systems like HS, which at the time was an early prototype, some benchmarks produce wrong results, so they are not included.
That's pretty interesting because, yeah, I see that on the analytics benchmark here, none of the systems really were able to speed it up very much. But then if you look at other ones, like the weather benchmark, you can see that each of the systems has vastly different speedups. So you can kind of see that each of these systems is able to optimize the various scripts across the suite differently.
Exactly. So we can see that Koala, well, okay, we see that. So we hope that Koala fits as a key missing piece towards lowering the barrier to making research on the shell more rigorous. Hopefully it's going to be useful for the community and will inspire future research and accelerate innovation in the space.
I mean, yeah, as a completely unbiased third-party observer, I'm super excited about Koala. I mean, I have all these exciting ideas about optimizing shell scripts. Like, I've been thinking about automatically making them reactive. I've been thinking about automatically making them fault tolerant. I'm thinking about optimizations that do fusion, running them on GPUs. I even have this idea about making times-traveling shell scripts. And with Koala, I can test these ideas out and see how well they work.
I'm so excited. So to summarize, Koala is a set of real programs written in the shell alongside real inputs. It comes with an extensive characterization of each one of the benchmarks and alongside configurable and automated infrastructure. Please visit cavemen.sh to find out more, and we're happy to take questions.